Włączony. Okay, I guess it's time to start. Hello, everyone. I'm Łukasz. I will be your host today. Okay. Yeah, it works now. So big news for today is that we have a new partner. Paramount joined us as a sponsor, and as you can see, pretty cool office, and I hope you'll behave nice, and we'll be back here soon. As usual, we are looking for help in all sorts. So we're looking for volunteers that are happy to help with coordination, event facilitation, looking for venues for speakers and doing marketing. So if you're into that, let me know. We are looking for speakers. Every idea is worth sharing, even basic topics or some super nerdy stuff, as Mateusz will show in a minute. I guess, yeah, that's right. Okay, and yeah, we meet on Slack, so if you are not there, I invite you to join. What's coming next? I already can let you know that we plan to have another meetup in May, 16th of May, probably. So if you want to be a speaker at our meetup, let me know. Today, yeah. So we'll start with Mateusz about one of the most important libraries in Scala ecosystem, I guess. That's the correct way to describe it. And then we have networking break, and then Jędrzej will tell us a little bit about the best or the worst IDEs in Scala space. And after that, we'll head for a couple of more beers, and I think we'll be going to Hopito at Żurawia. Right. So a few last things. If you want to tweet or contact us, there's a Twitter handle. Our event is live streamed, and yeah, the sponsors of this meetup is Paramount, of course, and iterators. Let's give them a warm round of applause. Yeah, thank you. And yeah, remember to grab something to drink. Here's a kitchen, and you can find stuff in the fridge, of course. Right, so as I already introduced before you, Mateusz, we've talked about Chimney.
All right, so hello everyone. My name is Mateusz. I'm one of the co-authors of the library named Chimney, and today I will try to talk about how this library can be useful, how I'm using it, what kind of features it has, and today we're not going to dive into how it works under the hood, because it's intended to be like beginner-friendly presentation. So a little bit about me. I've been working in Scala for about 9 years, so I deployed my share of bugs to the production. In the meantime, I was doing a little bit of open source, and the most successful library of them all is obviously Chimney, which I'm going to talk about today. In next month, this library will finish 7 years since we started developing it, so it's it's a good time for us to start thinking about making it, stable, because like as many things in Scala, it was thanks. As many other libraries in Scala, it was used by countless people and always on version 0 something something something. So it's right now we're working on it to solve this issue and finally have the stable API. Besides that, I was also blogging a little bit at my blog, and I wrote a small ebook about Scala and JVM that apparently hardly anyone needed, because you know, people who know Java already know the stuff, and people who only know Scala will probably only know Scala because they're not interested in the stuff. Anyway, so how Chimney came to be. Something like about 7 years ago, I was working on some private project with something like a startup. It didn't work out, obviously. Otherwise, I wouldn't be working as a programmer anymore. But anyway, at the time, I tried to solve a kind of little issue, like I have a simple web backend. It was using something like, you know, Circe codecs for communication. It was using Doobie. Well, actually, we were using Slick because it was 7 years ago. But since nowadays people prefer to use Doobie, and every example I will intend to show will be using Doobie so that people will understand it better. Nowadays, we would also probably use Prototype and Kinesis. At the time, I was using Avro and Postgres, but I think the part when we are generating images can be skipped. We'll just show those free ideas when we are handling something in the main model, something which you have to encode, arriving as a JSON, and something which we shove into Doobie and take out of the database, as an example. So yeah, the example that I had in mind, I hope you see something. Basically, it started with we're starting with something very, very simple. We have some very trivial invoicing program. By very simple, I mean the only thing we're handling is that we get some JSON with invoice, and I simplified it a lot. No invoice looks this simple, but I didn't want to, dive into the unnecessary details. Imagine that invoices are this simple. We get this kind of case class which represents an invoice, and some poor soul will send us this invoice as a JSON. We'd have to decode this JSON, shove it somehow into the Postgres or whatever using Doobie, and then reply with the updated JSON because the incoming JSON didn't have a creation date. So as you can see, this model is pretty dull. It has no smart things. Everything is basically a string, or long, or whatever. So basically no type safety here. This is very simple to handle. So we can easily generate the invoice using Circe's built-in auto-generation feature. Then, because we are not really interested in the format of the message that Circe is giving us, we are only extracting the message from the exception, so that we would have this nice either of string with the error or the other string with the output JSON, because this is very, very dull and very, very dumb service that someone would code if they were really, really short on time and couldn't code things in a proper way. So once we have this invoice parsed, we see that, okay, the creation date might be missing, so in such case, let's create it. And because we are some poor SAP who are not able to code things properly, we are using strings, so even though we create an instance from Java time, we're using string. And yeah, so we have this updated invoice, which we are sure to have a creation time. So we try to preserve it into the database. In a normal, proper application, you should have all of that things decomposed in the proper services, repositories, all of that stuff. But to have everything shown in a simple example, we're cutting the corners and showing the worst code that you shouldn't ever write. But at least you understand what is happening here. And so we are writing this SQL in the Doobie. We are putting all of those properties which we imported. This way we don't have to extract it one by one from the case class. We just import them all into our scope as if they were vols. Then we can put them directly into this nice interpolator of the SQL. Doobie makes sure that there will be no issues with SQL injection. It wouldn't help with issues like broken SQL, but that's why we are writing integration tests, or not. And finally, once we are sure that this SQL was properly inserted, we're cutting corners because we are using this transaction and then running it as unsafe sync so that people wouldn't have to look at those weird IO signatures. We only want to show people this nice IDE and pretend that things are simple under the hood. So yeah, the whole service basically get the JSON, parse it, make sure that it has a creation date, try to show it in the database, and then respond with the updated JSON to the user. Similarly, we have this get invoice service which assumes that there is an ID. We'll use this ID to fetch data from the database. Then, if we're able to get this JSON, we're serializing it. If we get this invoice from the database, then we can serialize it as a JSON and return to the user. And the rest is just some boilerplate I had to write to make sure that I could use some in-memory database for this example so that it would be complete. So I wrote some small unit tests for this code. Hopefully it will compile. At least it used to compile some time ago. Yes, it used to. So yeah, let's comment out an unworking example because that's what responsible people are doing. Oh, sorry, it was in the test. Yeah, it was in the test. Yeah, sorry for the disruption. Yeah, I guess it was this. Yeah. We can do. Did you save it? Oh, right. Sorry. IntelliJ idea, habits. Saving is not a thing. Things are saved out of the box. Yeah, so I wrote a little bit of integration test, which was just creating the service, using the database, all of that stuff. And as you can see, the tests are working. If you are curious what this test is doing, it's basically making sure that if we try to get the invoice before it was created, we should get an error. Then we should be able to save this invoice, and finally, if this invoice is saved, when we try to get it, it should be there in the database. So it's not really functional what I did. It's not really proper coding, at least according to some people. But for the sake of this example, it should be simple enough for people to understand what we are doing. So we were successful in creating this very, very simple and useless service, this example. And for most of the people, that would be perfectly okay. They would say, okay, our job is done, we can cache it and move on. But we can add some modifications if we were to maintain it for a few years as opposed to a few weeks. For instance, we might think that probably creation that could be instant to make sure that this is actually a date as opposed to some random string, because right now we are shoving random strings back and forth. So we could save just random string in the database and it would be okay. We could use some better ID like UID. And let's skip all the discussion what kind of IDs is great. Let's say just simple string with whatever we. Yeah. Let's just skip all the discussion. What is better, what worse. Let's just agree that an arbitrary string which is able to hold everything is not probably the best ID. So let's use something better for whichever definition of better you are signing up to. So that is something we can see on example 2. We improved our invoice. We use UID. We started using instant as a creation date. But we also wanted to have those nice JSONs which have creation-date. Basically, we wanted to configure the codecs. And in the meantime, because we started using Scala 3 and we were not very savvy in Googling things, we discovered that what was existing in Scala 2, CRC generic extras is not a thing. So we cannot just slap a configured codec and make sure that all of the fields are suddenly using this kebab case or underscore case or whatever. So, and we are still have a pressure of time. We have to deploy with speed. So we are finding the hard way that the fastest way of doing things without asking ChatGPT for 5 hours what to do is just start using this new field name, which is kind of awful. And suddenly, how we are using JSON is affecting how we are running on the main code, which is not very nice, but we are pressured all the time, so we just roll with it. And so our code is modified a bit right now. Happily, CRC is handling both instances and UUID, so we don't have to modify this JSON or provide any sort of things here. But well, when it comes to modifications, suddenly we have to use this new field name, which is kind of awful because we only wanted to modify how the JSON looks like, and then we were modifying how the domain is handled. So it's kind of awful. We also noticed that probably price on the invoice should be negative. So let's put a check here. But we are pressured on time, so we put it into this service directly, which is kind of awful because if you create this invoice any other way, it's still gonna slip in. And also with the Doobie, there's this issue because we didn't use a proper Postgres database with proper extensions from UUIDs and instances and whatnot. So suddenly we have to convert all of those smart fields into those dump strings that we are able to store into the database. So our choices also affected how we're handling the database calls. So things are like kind of spilling out, and it's not real nice. Also, when we're reading from the database, before we could just use nice little Doobie property. We just pass the case class, and when the Doobie will fetch all of those fields, and we'll figure out that each of those values should be used as a corresponding arguments of the constructor of this case class, and it's handled out of the box magically great. Well, not anymore, it isn't, because right now we are fetching strings and we have to use UUIDs and instances, so suddenly we have to parse those things after we fetch it from the database, and we cannot just have it. It is this really nice way. We have to write this manual conversion when we are getting this tuple, shoving things into the invoice and parse at the same time. So we try to cut corners to save us some time, but it seems that if we keep on doing this from this moment on, then, well, probably we will not be saving time anymore. We will be losing time. So perhaps we need to start doing something about it. So one of the things we can do is separating those JSONs from the domain model, so that the domain model would only handle things related to the domain, like making sure that necessary fields are necessary, the types we are used to represent things internally is proper. JSON should just be responsible for, shoving things back and forth to the front end. Similarly, we can have a separate model for the database operation so that we wouldn't have to work around things with Doobie, just use the simplest possible representation, and then when you obtain this model fetched from the database, think how to convert it into something more proper to internal processing. So if we attempt to do that, then we are having this kind of program. This is just an example of what we can do. So one of the things is that we can have a separate domain model. In this domain model, instead of performing validation somewhere externally and then hoping to not miss every place where it might be relevant, we could just make the constructor private and let's just parse all the arguments to make sure that when we create this value, it's going to follow all of the properties we want it to follow. On Scala 2, you would have to do some workarounds because this private constructor is not propagating to the copy method, to the subtypes. Well, basically copying and subtyping, I believe. If you wanted to extend it or use copy, then you could basically bypass this private. But on Scala 3 and on Scala 2 with the proper flags, this is working like as expected. You have this constructor. It can only be called by invoice class or its companion objects. And this way you can just make sure that whoever gets this invoice, they will not be able to break it, creating some broken copy or whatnot. Next thing we can do is creating this JSON class. It can be as bad as is necessary for the JSON library to be happy. And if people are looking at the variety of JSON libraries we have there, if you look at them long enough, you will see that all of them have their own issues. So you can never assume that it's going to work perfectly out of the box. There's always something you have to tackle with these libraries, putting some configurations here and there, probably changing how the things are arranged, just for the sake of getting the JSON as you expect it to get from the Swagger or whatever you're using. So if you keep it as a separate case class, it's much easier because whatever mess you're going to do, you just do it only here, not in the domain. But there's the question how to convert to and from the domain object. So the easiest way would be to just create some conversion method. As you can see, we have one here. This method makes sure that we have the creation date in case this option is empty. Then it's gonna parse whatever data we passed here. And then we receive this validated, this smart constructor, which will either create this invoice, which is following whatever invariants we put on it, or an error message. So no way we can mess it up. Same when it comes to converting from the domain. Usually when we are converting from the domain to the JSON, there's no way to mess it up, so there's no reason to use either. We can just always create this JSON out of object that we are assuming is correct. So that's why there's no either in the signature. Similarly with the database invoice, this object is dumbed down so that it would only use those types that are supported by the database of our choice. And as you can see there, all of those conversions, like making sure that we parsed UUID properly and that we handled the exception that might have been thrown. Same with the instant from the Java time package. So we shove it just to this one single method, and then we are done. And just as with the API invoice, conversion from the domain object to the DB object is pretty dumb, because if we're assuming that this object is always correct, then there is no way we wouldn't be able to find how it's represented in the database, right? And so when we look at our program, it's a little bit more cleaner now. We can just decode using this API representation. Then we are converting it. When we are handling the database, you don't have to do any sort of workarounds. We're just passing simple values. No need to convert them into anything. When we are getting things out of the database, we can just query for the object that we want to query. No need to do anything with those values, and then we can just convert it to domain, and the validator will make sure that it is correct objects, that things between what we got in database and what we are expecting to be correct in the application, things didn't started to mismatch. So it looks nice. It's really nice, actually. I would be really happy with this code. But let's look at the test. When we did the first modification, when we started to introducing types and things like that, we haven't run the integrations. Okay, so after we introduced those types as opposed to string everywhere, things are still working. Then we did our small little refactoring, which makes all of the code clearer and easier to read, and everyone is happy, and we should be able to deploy it to production like immediately. Except we cannot, because in the process of shoving all of those strings around, we swapped 2 fields around. As you can see, the expectations for seller and buyer are swapped. So somewhere when we were writing those really, really dull code, when we were converting from one case class to another, we made a simple mistake because, well, there's a lot of this code and it's really, really dumb. And when you're working with such a dumb code, you stop thinking and you just want to be done with it. You just want to, finish the job. And then we find out that this is the place where those silly bugs are slipping in, because this is not the part of code that you would be really focused to try to find the error. So what could we do with this kind of silly mappings? Because as you can see, it's kind of error prone. You can easily fix that error once you know where it is, but it would be nice to not have it in the first place, if possible. And also, so far it was a really simple model. It had 5 fields. So imagine you are having 10, let's say 30 such a case classes in the domain, another 30 in the API, another 30 in the database, and they're constantly evolving, and you have to fix them and write them, and then a new model has to be written, and it's really, really boring at some point. And when you are bored and your mind is, turning off, things can happen. So it would be nice if we could just, kind of extract the essence of this transformation. If they're really dull and there's no manual intervention required, it would be nice if we just didn't have to think about it at all. If there is something we have to manually intervene, it would be nice if we just saw it explicitly. So, well, the answer, if we can do something about it, is yes, we can. And that's basically what we wanted to show today. So there is this tiny little library called Chimney, and right now I'm mostly focused on just showing you how it can simplify the code. Then we will start talking about how it's actually working and what are the assertion expectations, what you can do with it, and what not. So, well, the smart constructor is something that you have to write yourself. So, sorry, but no workaround here from Chimney or any other lab library. This is basically something that you have to do yourself. But when it comes to the transformations, well, sorry about this. Constructor is showing error that isn't there. In case you are wondering if this is error then not, when we'll show this example which is Chimney as a refactoring, it's actually working. So just ignore those red squiggly lines. So let's start with this part because it's simpler. When we try to convert the invoice into this JSON representation, basically we're assuming that it's something that shouldn't fail. We always are able to create JSON representation for domain model that is always correct. So those two models are very, very simple. And the only difference between them is actually that the field name is different. So that's what this transformation does. It just says that, okay, let's take this object. We want to convert it into this kind of object. And when you see that this input type has this kind of field name, you should pass it to this field name in this target type. And as you can see, this is using the syntax the same as with those anonymous lambda methods when you are just, extracting things. Similar thing is available in QuickLens when you are saying how to handle nested things and update them. Here we can use them to just basically point how the field name changed in this example. And so this is like the simple transformation because it cannot fail. But what if we have a transformation which could fail and, for instance, result in an either? This is what's happening when we are converting into the domain object. So we're starting with this API invoice object. It's this. And curiously, there's something called partial. For now, all you have to do is that partials are representation of something like a, partial function. When you have total function, every single input can be handled. When you have a partial function, some of the input can't be handled. Except that we didn't want to throw exceptions at you. Instead, we will prefer to return some sort of result type that would have a proper encoding for exception thrown or empty value when it's optional, or some string error if you provided yourself error as an either. So when we are using partials, we basically are assuming that this is some transformation that could fail. And out of the box, as you can see, we don't have to say how to call the constructor here because this constructor is public. But this one is private, so how we can construct this object? Well, we can also provide the constructor ourselves, and with that we will be able to tell this transformation, okay, when you will be creating this type, you can use this method which will be returning either of a string or correct objects. Take a look at this method, and take a look at its parameters, so that when you will be moving things from these fields to this function, try to find the correspondence. Like if you can see ID on one side, then you try to find ID on the other side. If you can see that this is called seller, try to find the argument of this method which is called seller. And because those functions have basically the same names of corresponding fields, we don't have to do any sort of renames. But we have to handle this creation date because here it's an option and here it isn't. So we're telling the code explicitly how to handle this type mismatch by providing the value. We have this method with field const. And supposedly it's enough for the library to figure out how to create this new version, because which we know because the code compiled and worked. For the fans, we can try in a moment to not use this and see what is happening. Basically, but before that, we can see that with the DB, similar things happening. When we're commenting database object to the domain object, we know it can fail, so we're using this constructor. No other, the provided constructor, no other customization was necessary. We only just make sure that the OR format written by Chimney is converted to the simple string, and that's it. The rest of the code hasn't changed. The only thing that changed is that we're not writing those conversions ourselves. We just telling the library to figure out as much as possible on its own, and only forcing us to provide things where things are like ambiguous or if there are some missing values, etc. And you can see that it actually does those things if you, for instance, commented out one of those things, because now if we try to compile the code, we got nice little error, which is saying us that, sorry, my friend, you cannot do this because in this invoice you want to create, there's this field, and there is no field with the corresponding name in this value that you want to convert from, so you should do something about it yourself. So this way we always know which of those values are the one we have to handle. Similarly, if we didn't comment I did this, but instead remove this constructor, then the library would say that, sorry, but we cannot support this conversion. We can improve those error messages, but for now you can see that there is no way of Chimney to figure out how this input should be converted to the output. This error message doesn't necessarily tell you how, but we can guess that it's because of this private constructor. And if we don't want to guess, we could basically ask it to tell us how it tries to figure out what is happening. Ah, sorry. I haven't saved or... Weird. Okay. Ah, sorry. I remember. What is the flag? Server false, right?
Oh, right. Yeah.
Yeah. So.
Server equals false. Before the.
Yes, so this is a small shortcoming of the Scala CLI, unfortunately. But basically, when yes, basically, when we are working with macros or things like that, we are able to provide to use the macros to provide like the info or the diagnostics, and Chimney actually does it. So when we are generating this macro, you can see that we are actually logging every single step of the way, how this value was created. So you can see that we are starting with assumption that it's going to be a partial, so something that we can fail. There are some flags passed in that we are overriding some of the values. But at first we are trying to look at the implicits. We haven't thought about this, but yes, we're trying to look at the implicits, and sometimes we even use them, so that we wouldn't generate the code if this code is already available. We can take a look if we are using subtypes, because if you are, for instance, trying to convert, I don't know, string into any, basically whatever we have to do is just upcasting. So we'll just do this, and that's it. We have also several handlers for options. We'll talk about them later. We have some handlers for value classes, and finally we are reaching to the product. The product, and product is just a fancy little name of basically a class with extra steps. So we can see that, okay, we find out that this class API invoice have some getters, like ID, which is defined in the constructor, the seller also in the constructor. There are some values that you haven't thought about it, but which are coming from the Scala free, because every single case class is kind of like a tuple. Yeah, and basically this case class mostly has only things defined in the constructor. And then for each of those values, we try to match it. The match can be done like with this overrides, like this TSL that we seen before, or it can be done with some matching based on name. And you can see that the code is basically trying to match every single thing one after the other recursively, and after each successful matching and recursive resolution, it prints what kind of expression you get, and so at the end of the day, you can also get the whole expression. And this whole expression might be a little bit scary, especially if you are trying to override some values, because when we are overriding values, basically we have to aggregate them somewhere. So all of those with field counts, with field computer, whatever we are using, basically we're shoving things into some vector of any, and then when we are expanding this macro, we're getting this out of this vector of any. So things can look a little bit ugly, but can you hear me? Okay, great. So basically, as scary as it looks like, you can debug every single macro and figure out at which step something went wrong if you ever wonder why it went wrong. So if you ever thinking that, okay, I'm not going to use this library because I don't understand what is happening under the hood and I do not know what kind of code it generates and whatnot and how it could work, and whatever. Basically, all you have to do is when you're transforming, just call this little method and you are enabling macro logging. And because we are not using print lines, we are using this compiler info, then as long as you're not using Scala CLI without server false flag, it's gonna be always printed out in your whatever build you're using, SBT. If you're using this with SCAST, all of this code you could see in SCAST, all of this code you can see in Scala Metals. From what I saw, even IntelliJ happened to work with it. So you can just, add this little piece of code, make things recompile. Obviously here the metals forgot that we are existing, but anyway. But anyway, all of these macros are debuggable. Oh yeah. Now that we restarted it, you can see that. You can see all of this nice little text inside our favorite IDE. So if you're wondering what kind of output and how long the derivation took, you are just one little option away from figuring out what the macro does and how.
Stop. Show a compilation error. Comment out something. So it will break actually and show the debug.
Oh yeah, sure.
You deleted the logging method.
Under debugging as well.
Sorry?
Under the macro debugging as well.
I remove macro debugging. This is always shown when
Cool.
so this error, like whatever you're seeing in the console, you're also gonna see it inside Scala Metals. I think also newest version of IntelliJ. So whatever error you have in macros, you can read it and see, okay, this is not working for this and that reason. So if you you have provided this constructor, but you forgot to handle this single field, you have the information that you haven't handled this field inside your IDE. So basically that's what is the biggest reason we are using Chimney, like handling this sort of transformations and trying to provide as good user experience to the developer as possible. So a few of those things that Chimney is doing out of the box, I put on slides to just explain a little bit, at least as much as we have time. So basically, the base use case is converting from case class to another case class. As you can see, you don't have to have exact matching. You can swap the order around, and as long as every single name here has a corresponding name here, it's going to be handled. You don't have to do anything.
This also matches for the types or just the names?
It only matches names. If the types are mismatched, It's
For
tr-
the implicit
it's try it will try to figure out how to convert one field into another. It will look at the implicit as the first step, but if there are no implicit, it will try to check, okay, if this is a case class, to a case class as well, and then try to do this recursive transformation. Obviously, if some field is missing, like here, you have this extra field, so as we saw before, if it's not handled, you have to do something about it. You have some method like with field const or with field computed. With field const assumes that you know the value before and you're just providing it. With field computed assumes that you're taking the whole object that you got here and pass it into some function which will try to figure out what to do with it. Here might be not, in some cases you might think it's not necessary to have this object yourself because you're probably thinking, okay, but this object is in scope. But sometimes when you are trying to do some, like, let's say, anonymous function, imagine you put underscore here. It would be nice to have this objects anyway. Or if you try to do this derivation for a whole type class, for some other example, then this method is also very, very handy. Even though we're writing, saying that this is like case class to case class, you shouldn't assume it's a case class to case class, to be honest, because this mechanism, which is looking at the values which are available here and at the constructor parameters that are expected here, basically your input can be any class. Whatever class you have, even abstract class, is the allowed input. And whatever output, whatever non-abstract class with a public constructor can be used as the target of the transformation. It will just look at the constructor, look at its arguments, and try to match arguments with the values available at the source. So even though the case class is like a nice little intuition, it works for a bigger variety of cases. It also works with Java beans, but we don't have time to show all of that stuff. It's in the documentation. Another use case is like ADT to ADT. So this example uses Scala free syntax because it's much shorter and because we don't have much time. So the curious thing is that when you look at the case class to case class, you can see that you can have an extra fields on the input, and this just will be simply ignored. But on the output, all of the fields have to be matched. And with those ADTs, so enums, sealed traits, sealed abstract classes, Java enums, it's the opposite. So you have to, when you are pattern matching, for each case of this pattern match, you have to find the right matching. So all of the input subtypes have to be handled. So you can have an extra target subtype, and there's no problem. It's gonna just be ignored. But if you wanted to swap things around, then you would see that you have to handle it yourself. And with those newer Chimney releases, those milestones for version 1.0.0, we provided a little bit better aliases. Before we were calling this method with coproduct instance, and as far as I can tell, if I ask who in this room understand what is a coproduct, raise your hand. Exactly. That's why we decided to deprecate this name, and it's still available, but we're just deprecated it. Instead, we're having aliases like with enum case handled or with sealed subtype handled, so that you would know what is the purpose of this method. Here, if you want to handle this bus subtype, because it has no corresponding subtype in this ADT, you're just handling this enum case yourself. Well, there's also collections. We put some effort to make sure that collections are also being properly transformed. And as you can see, when we are converting like list of sources to the list of vectors, also those are the same sources on target case classes as we have with the case class example. So you can see that, okay, there's this extra C field that we can ignore when we are converting to the one side. List and vector will be also like nicely handled. But the fun things start when we try to convert the other side, because we have to provide value for the extra. And as you can see, the DSL allows you to basically provide value for every single value of this vector. This is one of the newest additions, so that the DSL feels more complete. So right now, if you try to convert a list of this kind of values into a vector of this kind of values, and you'd see that, okay, but where this value comes from, you have to provide it yourself, but how? Before you have to basically provide some implicit to handle those things, but right now you don't have to. You can just say, okay, for every item in this list, when you see this field, use this value. So this is one of those newer additions when it comes to the newer versions of Chimney. Similar also available for maps. And right now I'm working on the improvement to Chimney so that you could also use this DSL and this kind of override rules if you work not only with the standard collections, but also with the collections provided through some integrations, so like Java's collections and CATS collections, because CATS provides things like chain, non-empty list, and empty things. So in a long term, 1.0.0 releases are is aiming to provide this sort of DSL to basically every single collection that the Chimney is handling. So it's going to be pretty nice. And that's mostly everything I have prepared for today. If everyone is curious, I can show some REPL experimentations. If everyone is curious and have some questions how something would work. But if not, then we're going to finish it. So are there any questions so far? Yes?
Test. Oh, scary. Okay, maybe some backgrounds. I mean, in a recent project, other engineers have been using it sparingly. In the past, I used something like Monocle. This is kind of like, it's similar, not the same, right? But the main problem with Monocle that I had was sort of making it a no-go for some things is performance impact. And my question would be for Chimney, is there performance impact, you know, on runtime when transforming from like a highly nested case class with other, like, you know, super complex stuff into another complex thing? Is there a penalty for this? And then second question would be kind of coming from Monocle, like you showed with fields computed. Given source and target are the same kind of case class, this sounds like what Monocle kind of does. It gives you a better copy, so you don't have to manually copy. And in Monocle, unfortunately, there was a performance penalty actually for using their thing versus manually doing it. And I'm very curious because I would want on the new service also to use this maybe. And I'm thinking of options. Thank you. Great talk.
Okay, so the first thing, like the difference between Monocle and Chimney. Monocle is a lens library, so the idea is about, as you said, creating a modified copy of whatever you have. So the assumption is that you are always trying to, you know, just a copy on your case class, or just, you know, return a modified copy of whatever you're having. And it just provides some nice little additions to do things in a, you know, nested way. With Chimney, it's kind of like a other way around. Chimney tries to figure out the simplest possible way of converting one type into another. So if the types are the same, Chimney thinks, okay, my work here is done. So if you try to like think about mapping from one type to another, and you can see that basically every single leaf is either implicit provided by user or assumption that, okay, this is a subtype of this type, so we don't have to do anything with that. When it comes to the performance impact, there is some small performance penalty coming from the fact that we are using this DSL. When you can see that we have these things like, okay, this like a Fluent builder, this Fluent API. Every single time we are adding some value here, like this constructor or this or this value here, we have to aggregate it somehow, because there is no way of just inlining everything in such a way that those things like would be directly copy pasted into the right place. So our way of dealing with that is that we are having vector. And from our benchmark, this vector has some impact, but most of the time is negligible. There are some other libraries which are using different approaches, like ducktype, which are not ducktype, sorry, which are using single transform when you provide all of the overrides at once, and then you can like erase those intermediate representations. So it should save some allocations there. But on the other way, when we are dealing with those failing transformations, we spend a lot of time on writing benchmarks and making sure that when you're converting one type into another type and the conversion can fail, that the overhead of this partial transformer is smaller, especially when you have things like fail fast or aggregating errors, because this what this partial does is not only is used as a but either it's also like aggregating errors. So you can have every single value that failed conversion. You can see, okay, this will fail, this will fail at this will fail at that, and we did this in such a way that it has less overhead than using either of lists of strings. When we are like comparing those representations, we made sure that for this task it has as little performance overhead as possible. Meanwhile, a ducktype tries to use some generic f with some type classes for providing arbitrary effects. So on one hand, they can erase some overhead because they're inlining the variables directly, but on the other, because they have arbitrary f, they have no way of optimizing it because they know nothing about structure. So I would suggest that if you really need this performance, then there are like two things to do. First of them is to basically write benchmarks, and the other is that pay attention, because there's a small little difference. It's described in documentation, but let me show. When you see this transform into and into transform, one of the roles of this change is that so you knew that okay, this representation is directly getting this like type class transformation, and this one is providing some customizations. But the other reason why those two are different is that if you use this into version, then basically the code generated by transform is inline. You're not creating a type class, you're creating the whole value with the inline transformation. So you can save a few allocations. Also, like when we are generating this nested transformation, one thing is that we're trying to avoid wrapping into partials we don't need to, and the other is that we are not creating intermediate transformers unless they are provided by the user. If the user is not if the transformer doesn't come from the user and transformation comes from us, we are not creating the type because we are having inline code. So with this code, you would have only like one instance of the type was created, and with this code, you would have, I believe, 0 instance. You would have only inline code, so that should spare you a few allocations. It might not be enough because we're still using this vector, but if you benchmark, you can see if it's affordable for you. I hope that answers the question. Any other question?
I really like showing stuff, so that would be great if you have more questions. Otherwise, I have a question coming from the live stream. Well, you actually answered that partially already, that this macro logging works in IntelliJ as well. Can you expand, like, is it working well, or?
My experience is that with IntelliJ is sometimes like a hit or miss. I believe IntelliJ is working on a way of incorporating some feedback from the compiler directly. but it's not working perfectly. So sometimes I saw that there was no hints from the compiler or whatever, but sometimes I saw that when I compiled the code, for instance in the terminal, then error started popping up inside IntelliJ, and I could just hover on the line and see that ever happened. So I believe they are working on it. They're not 100% there, but I can see that it is possible. In the future, we will have better support for all sort of things coming from the compiler directly.
Okay, thank you. Person asked a good question. I have a question myself. So what would be your go-to resources to get to know Scala's 2 and 3 macros and how to work with them?
That's a tough question. I believe there are very spare, user-friendly resources. When we could see on Chimney site, I'm not sure if I have internet. Probably. Oh, I have. Okay. Okay, but it's gonna be faster if I just. When working with Chimney and trying to provide as much information for the possible contributors as possible, basically I tried to pick up some sources that users could use. So, of the things that I believe are potentially useful is first having an IDE which works kind of good. Depending on which Scala versions you're using, 2 or 3. In Scala 3, try to always have quotes Scala open. It's inside the standard library, let's say, in Scala 3. Either load the when you're working with IntelliJ, you might read either the source or the tasty file. The tasty file will have all of the comments stripped, so it's gonna be slightly harder to read. So try to read the. Yes, dude, I check it. In IntelliJ, you can write either. You can accidentally open the quotes tasty, and it will have all of the comments stripped, so it will be less useful. But if you open quote Scala, either in IDE or you will find this file on Scala free GitHub repository. Then it has a lot of comments and all of these methods available inside. Similarly with Scala 2, I think I have a PR with updated version of this where I have a few more sources. There's also Scala 2 macros documentation on the on the Scala language, but it's with this picture of here's the circle with the owl and then the rest of the owl. So it's very basic. I would just recommend whoever work with the macros just assume that the easiest way of achieving anything is get an expression with the code you want to generate and print the IST of this code to see what compiler does to get this stuff, and then by trial and error you start to figure out how to do these things yourself. Looking at those files also help, and there's also APFL papers. So when you click on this, you could see that there is quite a lot of papers about Scala, and of course they're not written for normal people; they are written for academics. But if you are very desperate, then there's also that. But yes. So in a way, I would say there are some resources. It just not many of those resources are, aimed toward the user. But if you are really interested in learning, then one of the past conferences I was attending, I had basically comparison between Scala 2 and Scala 3 macros, and you can have both the slides showing. Some differences, as well as a lot of examples of some very simple macros, how they would look in Scala 2, how they would look in Scala 3, which you can use as a way of studying and, starting up. All of these require only Scala CLI to work with.
Thank you, Mateusz. I think you deserve a warm round of applause. There's one more
Thank you.
question before the break. Like, how many beers were involved in creating Chimney? Ballpark number is
How many what?
beers.
Oh, how many beers?
Yeah,
Countless.
countless. Okay, that I take
You
that
cannot
for
do
an
this
answer.
for sober, sorry.
Okay, so yeah, speaking about beers, grab one from the fridge, and the pizza's already waiting for you in the back. So enjoy that, and we'll be back after a short break. And of course, enjoy the conversations with fellow developers. Okay, welcome after our networking break. I hope you are rested, hydrated, and also had some pizza. And now we'll have Jędrzej. Jędrzej is a big fan of vermouths, Madrid, and okay, thank you. And he's also an expert, or first and foremost, an expert on Scala tooling and all things related. So, warm applause for Jędrzej, and have fun.
Hello. So thank you for the introduction. I will introduce myself again in 1 second, but I welcome you to my talk. It is a very talk that I made in a very quick iterations. I made it on Saturday. I called it "The best IDE is your favorite IDE," but I think we can call it "The best IDE in your favorite IDE" because it will better match what I'm trying to show. So I personally work in Virtuous Lab, and I work at Scala Center, where I try to improve Scala language. And if I were to quickly describe what I do at those organizations, I listed some organizations I belong on GitHub, and I do different stuff in each of them. So first one is Scala language. So I'm a Scala free compiler engineer in this organization. At Virtuous Lab, I was IntelliJ plugin developer. At Scala.js organization, I was Scala.js frontend developer. In Metals, I'm a tooling engineer. And at Scala Center, I'm a backend developer working on Scasti. So let's begin. And yeah, this is basically a summary of what I've just said. I work on various tools, and as I said previously, one of them is Scasti. I introduced completions in this tool, and as you can see in this example, they just work. We also have metals. The same snippet, almost the same. We wrapped it in the function, the main method, and it also works. This is a very simple snippet, right? Just a println. And we have IntelliJ, and it also works. No surprise. Why wouldn't it work? Yeah, but this is not your average project, right? I hope this is not your average project, because in your average project you have something special, and this something special is a macro. And what is exactly happening in this case is a transparent inline macro. I don't want to explain how it works, because this is not the point of my talk. Paweł Marks did a great explanation in his talk. But what I'm trying to show is that this macro, which basically takes a map of strings and some other values, get transformed into a typed version. So in this example, we can see that we try to run this macro, type-safe-config, with 2 keys and values, right? So first is domain, which we set to Scasti, and then is a port set to some number. So metals can deduce what type are those fields after the type checking. So if you look closely at the completions, the second and third item is typed element domain of type string, because the domain is provided as string, and the port is int, because we provided it at int. And in macro definition, it was any. So metals can deduce this. And IntelliJ sadly can do this. And I'm not here to tell, oh, it can't work in IntelliJ, IntelliJ is worse. I'm here to show you that it can be solved. And it was already done 1 week ago by Igal. So he plugged metals via LSP, which is available only in IntelliJ Ultimate Edition. So this kind of work, his solution was genius. When I first saw it, I was like, how did I not think of this? So what he did is he not plugged full metals and replaced IntelliJ. He replaced macro evaluation with metals. So only macros were parsed by metals, and all the other stuff was still working from IntelliJ. So this is a pretty nice hack. I like it very much. But let's ask ourselves a question. Why did IntelliJ fail in the first place? Because this should work, right? The tooling should work. So I will do a quick recap how compilers work. I need to do this so we can get the underlying problem. So compilers have to do some iterations, but they mostly do a parsing and then type checking. They can do also other stuff, but those are two basics that have to happen. So let's try to parse this second line of this code and see how it looks like. So we have this Godfather series value, and we try to access a member head. So in AST, which is abstract syntax tree, a parsed form of this code, it will be a selection from the identifier Godfather series to the identifier head. So it's very simple, right? Let's get and make this example a bit harder. So now we change it to get, and now we provide some additional arguments to this method. And it is no longer a selection. It is now an apply, which takes selection and provided arguments. So this is basically how the tree this code would look like in the internal compiler representation, right? But this is only the first phase. The second phase is type checking. So in order to type check this, we have to also do some heuristics or algorithms. So in Scala, it would look something like this. First, we would go into the left branch of this tree and ask ourselves, okay, what are we trying to select? So we are trying to select something from a Godfather series identifier. So what is the type of this identifier? It is basically Godfather series.type. And why it is not a list of strings? Because Godfather.type is actually a subtype of a list of strings. It is in singleton type. And this is the most correct type that we can get in the compiler right now. So if we go further up to up the tree, we can get another type. So now we want to select a method get from this identifier. So the type now belongs to is Godfather series.get.type. It is also a correct type. And now we have done the left side of this tree. Let's go to the right side, and we have to type this argument. So this is 0. 0 is also a singleton type, so it's 0.type. And now we know that it's application of integer argument to Godfather.get.type. So underlying type of this expression is integer into t, but if we alias this, it's integer into string because it is a list of strings. So finally, we can get the underlying type string. Yeah, sorry for this. I had to do this this explanation because I will need this later on. This is not super important to understand. This is just a showcase how it works. So IntelliJ does stuff a bit differently because they have their own AST. It's called PSI. This is Scala Abstract Syntax Tree, and this is Program Structure Interface. It is used in their tooling entirely. So Java plugin, Rust plugin, C# plugin, everything works on those PSIs. It is the basic building block for all the features. References, go to definition, the linting you get, which tells you, okay, you used filter and had option, you could just use find. It is all built on PSIs. So if we check those structures, we can see that they're actually a bit different. And it is obvious that if something is different, we can't run the exact same algorithm as we had before. So we can't run Scala typer on those PSIs because this is a different structure. It won't work, it won't compile, it won't type check. So they had to not only implement own parser, they also had to implement own type checker. So this is not a bad solution. This is a solution which is a bit more expensive, but it provides you a different kind of benefits. So this is not bad, this is a trade-off. And if I were to create two axes and basically place metals and IntelliJ on those axes, I would say that IntelliJ, as of today, has very best error recovery. It just works. It loads your PSIs into the memory. It knows how to recover from error and how to find those erroreus definitions. And metals, on the other hand, are not so good at this, but they run true compiler underneath, so you are almost always correct. There are bugs, obviously, but you are aligned with the compiler. With IntelliJ, you are aligned to their re-implementation of the plugin. But some time ago, IntelliJ did a great thing, in my opinion. So they added something called compiler diagnostics. And this is a big change which improved Scala free experience in the IDE. So basically, they are no longer providing you the red lines with the errors from their type checker. They are using a true compiler to provide them to you. So the errors are now completely aligned. And that is a big benefit because you are no longer getting false positives and false negatives. And in metals, and because of that, we can move IntelliJ a bit to the right because it is now still not completely correct because completions, hovers, other features rely on their PSIs, but the errors are finally aligned. And it's a big deal. And with metals, we did something similar, but we are going up with the error recovery. So there is an initiative called BTasty, Best Effort Tasty, and it is basically a way to store trees with errors in a pickled form, which then can be picked up by the IDE and used by the IDE. So this means, in short, that metals will start working on projects that are not compiling. At least we hope it will start working on projects that are not compiling. But with this change, it will move up. So we can go, I think, one step further. And I had this crazy idea. So maybe we can do something like this and merge them together. And we can selectively choose what we want to do from IntelliJ and what we want to do from metals. Because some things are still better in IntelliJ, some things are better in metals. Let's just pick what's the best of both tools. So where am I going with this? Not all features require typer. And those that do are really depending on the true representation, which we saw in the beginning with those macro example. It required us to have the real representation, and IntelliJ can't provide it to us right now. It will in the future, for sure. They will fix this, but as of today, it can't. And metals can do this. And some other features are not so reliant on type checking. So let's go first over features that require proper types. So these are the completions, hovers, signature helps. This helps you the arguments which are required for the method. And the other features that don't require, they can be enriched with the IntelliJ indexes, which are very good. So go to definition or find references. Yeah. So metals can enrich IntelliJ, and I think IntelliJ can enrich metals. Let me take a sip of water. My solution, or yeah, IntelliJ is open source. IntelliJ plugin is open source. Yeah. So I did a thing. I implemented this, and Eagle also did this. But his solution, while it's ingenious and I really like this, it has one drawback. it runs full metals LSP in the background. So this is another compilation server on top of IntelliJ, which is actually believed to be second most resource heavy application after Google Chrome and metals, just before metals. So yeah. Let's go back again and check those examples, the simple examples. They just work. They have the completions, printlns. We again in metals have printlns. In IntelliJ we have those harder, in VS Code we have those harder example with macro. In IntelliJ we also have this with proper adjustments. But there is one thing that connects all of those pictures. And this is called Scala Presentation Compiler bootstrapped. And this is also another initiative taken by the Scala compiler team 1 year ago, when we decided that we should implement a presentation compiler directly in the compiler. Previously it was a part of metals, now we moved it back, and it is published along the compiler itself, just like Scala library. So this file, this library, provides you the basic utilities for a basic IDE, all the required things that you have to implement in order to, that you can use to implement the IDE. So first of them is the completions. And this is the API. This is Java API. It is completable feature, which it returns completable feature of completion list and requires offset params. We have hover, signature help, go to definition. And sadly, we don't have find usages because it turns out compiler is not so good at this. There are better ways to do this, at least, for example, indexes. And yeah. And with this library, this package, we can try and develop our solution. So right now, I will do a quick 101 how to write IntelliJ plugins. And at the end of this talk, we should be able to give you completions from metals, which don't duplicate work like LSP does. So I did this with ChatGPT, which turns out that is awesome at writing IntelliJ plugins. I was surprised. I couldn't believe it, but it is so good at writing IntelliJ plugins. I'm not sure, maybe it's because I used Java instead of Scala to do this. I mean, to write the examples prompts. But it helped me out really, really well. So in order to create a plugin, we have to provide it with few necessary things. So first, we obviously have to set up a build SBT, like in every Scala project. So this is a bit different build SBT because it requires us to provide an SBT idea plugin. And also, it allows us to provide some necessary stuff that will be passed to the plugin. And the informations like version, platform. So this plugin is targeting IDEA community from the version 2.4.1. And it runs on Scala 2.13, sadly. I don't know why Scala 3 doesn't work with IntelliJ. I suppose this is the reason is SBT IDEA plugin. And also we can pass IntelliJ plugins. So this is just like library dependency. This is plugin dependency. And we want to depend on Java plugin and Scala plugin because they have all the stuff that we want to reuse, right? And we also add this presentation compiler. So in normal application, we wouldn't add this right here. We would dynamically load it for your specific version because, as you can see, this is presentation compiler 3.3.3. It is specifically for this version of the compiler. You can't use this one with any other version. So you have to be very careful about this. But for the sake of this presentation, let's just use 3.3.3. And the second file you need is plugin XML. So it also is a description of your plugin, but the important thing here is the line 213, which allows us to add extensions. And those extensions will be places where we plug our new IDE features and reached IDE features. So let's do this, and let's try to create our own completion provider. So we will start with creating a final class. It is required to be final by the IntelliJ. PC completion provider, which extends completion contributor. So completion contributor is provided to us by IntelliJ Open API, and it has method fill completion variants. We will get to this in a second. But first, let's log that this is actually working. Then, normal person would shot a request to EMDB or Ask Database for Paramount movies, but I can't do this right here because I'm too lazy. I just asked ChatGPT to list those movies for me, and I hard-coded them, but you see only one. And then we can finally override this method. So this method runs at the end of the completions. It is used to enrich, add more of them, delete some of them, depending on your use case. And here, we just needed this. So it gives us parameters, which is the file, the cursor position, all the necessary means to know what file are we trying to complete on. And it also has result. And the result is a completion result set. And right now, we are diving into Java Scala. We are no longer in this perfect world of immutability. Now we have side effects all the time, because the only way to modify this completion list is to modify the result, because this method returns a unit. So this is not perfect, but we have to work with this. So let's try to transform those movies into something nice. So for each of those movies, we have the title and the year of when it was published. Then we want to create a lookup element builder. This is completion item in the IDE, single completion item with a title. And then we want to add a type text. So type text is something that is shown on the right of the completion item box. So we will see this in a second, no worries. We then add this to the list, and we stop the completions to not run any further, to not propagate to other runners, providers. So after this simple code is run, we also have to provide this extension point. So we say, this is completion contributor for language Scala, and this is implementation class. Obviously, everything is a string, why not? And it should be loaded first. And we will get something like this. We will have all the movies from the Paramount, which we can complete directly in our IDE. So we have created a very simple plugin, which does a very simple thing. And this is the first step to our solution. Because now we need to create something real. We now need to compute real completions. And I'm sorry for the later parts of this talk. This will be a bit of code, but I have to show it to you. It won't be much, but it will be some code. So let's dive into this. I would try to go slow and try to explain every line. Yeah. So as the comment says, we want in this place compute real completions. So at the first top lines, I added the signature of the completion method from the presentation compiler. So it takes offset params and returns completion list. We want this. So first thing we need is actually presentation compiler, so we can call this method. Let's not implement this right now. We will do this later on. We also need offset params. Let's ignore those. This is basically a file, the text, and the offset. Offset is cursor position. And then we want to run these completions and store them somewhere. And this is basically it. But now we want to transform them. Sorry for doing await on this completable future, but you can do this better. But for the sake of this presentation, I wanted to keep it short. And it is not so short when you have everything mutable. And yeah, I'm doing await. It works for this case, but it should be rewritten to the async version. So when we finally await those completions, we can get this completion item list. We can get items to get each completion item like this title and the year of this publishment. And then we can transform it into IntelliJ compatible format. So it is lookup element. And we add it to the list. So right now, we have the completions from metals, but we still have to provide the offset params and the presentation compiler. So with offset params, as I said, this is quite simple. We just pass a file URI, we pass the text of this code snippet that we are trying to complete on, and the parameters offset, cursor position. And then we need to get presentation compiler. So in this snippet, I used a helper method compilers get presentation compiler, but it is not implemented. So let's try to implement this. And yeah, it is object. Don't worry, that is final class. It is object. And you can have multiple modules. So let's start with the concurrent safe structure in the beginning. Let's create a tree map, which takes as a key a module. This is IntelliJ module, so it is just SBT module, basically. And it holds a presentation compiler reference. And then let's create a safe accessor, maybe, something like this, which creates a presentation compiler if it's not present and returns it to you. Yeah. So how presentation compiler is actually created? So we just run new Scala presentation compiler, and we instantiate it with a method new instance, and we are required to provide a name for this presentation compiler. This is not important. Full class path and Java C options. And where are we getting full class path from? We will see in a second, but this is the problem. We need a full class path. IntelliJ luckily allows us to quickly get this from their API, because IntelliJ allows you, it has to understand your projects. It has access to this information. We just need to access them for our case. So this full class path, we will get something like this. So we have library dependencies, which is a Scala library and Scala free library. And we also have module dependencies. And this is quite problematic because this is actually a target folder. So this is a folder which stores the class files produced by your build tool. And if you have multiple files, you need to have class files for them for presentation compiler to work. And with the PSIs, it is quite hard because PSIs don't produce class files. They don't need to. They operate in memory. But luckily, IntelliJ introduced this great feature I mentioned before, the compiler diagnostics. And I suppose they run full incremental compilation in the background, because when this is enabled, it actually produces class files when you save the file, so all the time. So we are always up to date with the changes in the files. And with this single feature, we have handled the incremental compilation, which is necessary for presentation compiler to work. And well, now we can run the completions.
What are those Scala C options?
You can also pass them, but via the constructor, not the different method, not here. I'm ignoring them here for the sake of this presentation, right? And we can see some completions. So we have print, we have printf, we have println, and those are provided by the actual presentation compiler provided by Scala. Yeah. So wait, that was it? It was so simple, kinda, but there is one problem that we still have to solve. So this snippet doesn't work. And why is that? It turns out that list buffer is not in the scope. So how presentation compiler can know that it can complete list buffer, which we expect in this exact scenario? So this is where index goes into help. And in metals, we have our own indexes. IntelliJ have their own indexes, and they're kinda not compatible with each other. So how can we approach this? This is not so trivial to generate index. It takes a long time when you start your project to index all the dependencies and everything. So I tried integrating it, and it turns out there is a way. There is always a way. Because presentation compiler is not the only interface that is published via the compiler. We also provide an interface called symbol search, and it requires for us to provide a way to get documentation for a symbol, definition for the symbol, definition source top levels, this is not important, search method, which is used to search a given query in the symbol search. Search method is the same, but for the methods, and yeah. It also takes symbol search visitor. This is a visitor which goes over those class files and takes symbol if they are matching your query or not. So we can just keep it. I will show it for you in a second. And this is what we want to implement. We need to find a way to get a implemented visit workspace symbol and a method search to make it work with the presentation compiler. I know this because I implemented this. This is not so. This is basically an insight, but it can work. And to do this, we have to understand what is this symbol, because it is said this is the string. But what string? it is like a path to this thing or something. So, and sorry, something is not working. Yeah. Sorry for this. My slides got mixed up. So this is a symbol. This is semantic DB symbol. So this is also something that was created by Scala Meta organization. And in Scala 2, it was an external plugin which was added to the to your build. And in Scala 3, this is built into the compiler. So it allows us to quickly store references during compilation, what is used where. So then we can find them very, very quickly. And let's quickly try to understand how it works. So in the first line of this code, we have object test, and semantic DB output of this is an empty package with the object test at dot. And it also stores occurrence that in the first line from character 7 to 11, we are using this test. And it does this for all the symbols. So in the main method, we will store that there is a symbol test.main, and we will also store a definition of a test main arguments. So we also store all the occurrences, not only test main, but also RI, string, unit, because they are used on those lines. And we also have println in the next line. So this is basically a semantic DB. This is semantic DB symbol for a string. And what we want to do is we want to take IntelliJ symbol, which is actually a PSI element, PSI from the program structure interface tree, the internal representation, and turn it into compiler internal symbol. And in order to do this, we have to do something crazy. We have to ask ChatGPT for help and ask him to write a method which allows us to convert PSI class to semantic DB symbol. So this method won't work, but it works for some cases. So I used it anyway, just to showcase you that at least buffer will work. So basically, we can, from this class, it holds enough information to get a qualified name. Qualified name is a name with all the package prefixes which are on those name on the symbol. So then we replace them with dots or slashes, and it will just work for classes. Yeah. And now we have to provide the instances of those symbol searches. So let's do this. We will create IntelliJ symbol search, which takes PSI short names cache. So this is cache provided to us by IntelliJ. It does this on the startup. You know this when you have this line on the bottom right corner, indexing. This is when cache gets populated. And then we want also a search scope. So we can limit the search to module, project, file, anything we want. Yeah. Now we have to provide this method search, which I told you that we have to provide this. And it takes a query. This is the completion prefix. So in the list buffer example, it will be list B, not completed version. We need build target, which we can ignore in this example, and a visitor, which is provided to us from the compiler. So let me also take a sip. Yeah. So right now, with those, with this method, we can try and get those classes. So I did this very, very unoptimal, in a very unoptimal way. So first, we ask if the query is long enough to even bother searching the index. It is very, very hard operation to do. Let's try to limit when we do this. Then we will get all matching classes. So we get all class files names, and then we filter those which start with the query. So it will get all class files which are seen by the IntelliJ, and it will return all that start with list B. And now we want to get the PSI element of this class, because we need a full symbol to get PSI element. And from this full symbol, we can run our helper method to convert this to semantic DB symbol. And then finally, we can run our visitor with semantic DB symbol provided. Other arguments are not important here. And we are at the end. We can now write those few lines. We can instantiate our cache. So we get the instance of the IntelliJ cache we create our scope, which is module with dependencies and library scope. And finally, we instantiate our IntelliJ symbol search. And the only thing we need to do when we have this index is to run another another builder method with search. And when we provided this, it just works. And we have list buffer completed from the IntelliJ index. Yeah, and I think that's it. Oh yeah, and the harder example also works. So this is a proof of concept I have created at Saturday, and I was motivated by eagle work. And I think this is very, very promising because I'm not here to neglect that IntelliJ or metals are better. I'm here to show that together we can do something better together. And one way to do this would be maybe doing a fallbacks to metals or fallbacks to IntelliJ when it is not capable of completing your code. So the future will show. This is just a proof of concept, but as you can see, it is possible to integrate both tools in non-invasive manner, which doesn't duplicate the work done by the LSP. Yeah, so thank you. And these are my slides. So if anyone has any questions, feel free to ask them.
Will there be any page with reference where to find if this idea will be usable? Like I would like to have more support.
Okay, so if I will have more information, because as I said, I hacked this during the weekend. You will know by the conferences because I will talk about it a lot. Yeah, but other than that, probably Scala space Twitter will be the best place to do this. It will end up there for sure if anything changes in this matter.
Thank you.
A little bit more general question, I guess. What is the best language to write IntelliJ plugins with?
Oh, that's a tough one. I'm not that experienced, but you can do this with Scala, and you will not have your life harder. It will full IntelliJ Scala plugin is written in Scala, and it is super big plugin. So I guess in any JVM language it is possible, but they provide the utils for Scala, Java, and Kotlin, obviously.
Cool, thanks.
Yeah.
Okay, so Jędrzej, just maybe one question from me. So can you confirm this is happening? Because on the live stream, somebody already suggested the name IntelliJ for that. So is
I don't want to
IntelliJ
steal
happening?
don't want to foresee anything because, as I said, this is just a proof of concept. But yeah, you can run metals in IntelliJ already with the ultimate version. And also, I know that Red Hat is doing a community version of the LSP protocol, which will also run metals without ultimate version. So, I don't know. I can't answer this question. I just don't know. We will see in the future.
Okay, one question, because it's like run metals in IntelliJ. I'm more interested in the other way around. So can I used to run a headless Eclipse and use that in Vim. So can I run maybe in the future some headless IntelliJ, get their PSI and actually have fun in Vim in my terminal setup?
You can install IDE Vim plugin, right? Yeah, but other than that, I'm not sure.
I don't want their GUI. That's like
You have to ask IntelliJ team.
okay, that's fine.
You have to ask IntelliJ team. I don't know.
Okay, but that approach is more interesting. You know.
Yeah.
Because it would give kind of the nice things that they provide and actually provide this back to kind of like an open community.
So what I see is the most promising here is the eagle hack. So replacing Scala macro expression evaluator with the metals. And in his POC it worked for some cases, for some it didn't. But yeah, it is just a very promising idea. And we will see how it develops. As I said, this is just a proof of concept. This is nothing serious. It is super slow right now because, as you've seen, this code is very unoptimal. I did awaits. I fetched all symbols from the cache. This can be done way better, but it still is faster than IntelliJ, I think, when I tried to benchmark this. So, yeah.
Okay, any more like extra questions after questions? No? Okay, so thank you, Jędrzej, very much. You deserve a glass of vermouth, that's for sure. And also a round of applause, of course.
Thank you very much.
So that's it for today. So thank you for attending. Also, another applause for our host, Paramount. Thank you. Thank you. Yeah, you had your beer and pizza, and now you have to pay for that by filling out this form. It's a little bit of feedback for us how to make these meetings more interesting. So please fill that out. And yeah, we'll be heading for some more beers at Chopito, Żurawia. We'll meet in the corridor downstairs and we can go together, or you can just walk yourself there. It'll be fun, so I suggest you go there. Yeah, so thank you very much. Make sure you don't leave anything behind, and yeah, have more fun tonight. Thank you.